So a radius goes from the center to a point on the circle. What's a diameter? All the way across, but it has to go through the middle. If it doesn't go through the middle, it's not a diameter. So if let's draw it over here. So it has to be from one edge through the center to the other edge. So the key is that it has to go through the center. So edge through center to the edge, to the other edge. So that's a diameter. It has to go from one side through the center to the other. If it doesn't go through the center, it's called something else. So that's why the center is the most important part of our diameter. Okay, does anyone remember how many degrees are in a circle? 360 degrees is a full circle. What's a semicircle? A half circle. So how many degrees are in a half circle? 180. These are two facts that we're going to use a lot today. Are the fact that the whole circle is 360 and half a circle is 180. Okay, an arc. An arc is a part of the outside of the circle. So from A to B, that's just a section of the circle, right? So we would call that arc AB. A minor arc specifically is an arc that is smaller than a semicircle. So minor means smaller than a semicircle. How do we label it? We label it with 2 points, the endpoints. So if I'm talking about the arc from A to B, I would write A to B with an arc over it. That means arc AB. Major arc, that's an arc that is larger than a semicircle. A semicircle is its own name. It's kind of like how with acute and obtuse. Acute is less than 90, obtuse is greater, but 90 is right. So same idea, less than semi, minor. Semi is its own name, and then major is above. When we label a major arc, we need to use 3 letters. So if I was going to do major arc starting at A, going this way. So I go past C all the way around to B. I would have to say where I started, a point in the middle, and the end point. Because what that does is it helps us determine the direction. So the A and the C start and finish and what you went through in the middle, that helps you just determine the path that your arc is, so that we don't confuse it with AB, the minor arc. That's what that middle letter is there to help you with. All right, next up we have a central angle. A central angle is an angle made by the center and 2 radii. Radii is the plural of radius. So when you have 2 radiuses, that's too many S's, so we say radii. So 2 radii, so AO and OB are radii. The angle in between, that's called a central angle. Otherwise, you can think of it as an angle in the center. If I tell you that this angle is 80 degrees, what would this central angle over here be? (360 minus 80), because remember our all the way around now is 360. So we kind of have to break our habit of always doing 180 like we did with triangles. So 360 minus 80 would give us 280. Okay. And then our last vocab term for today is arc measure. Arc measure is the degree of the arc. Whoops, not of the. How you write it is you write a little m before you write your arc. So m, that means measure of arc AB. And one of the nice things about measuring arcs that have central angles, the measure of the central angle is the same as the measure of the arc. So see how this has endpoints AB? That means the arc from A to B will also be 80. Just like major arc ACB will be 280. And the measure of arc ACB will equal 280. So these are the vocab and the terms that we're going to be using in today's assignment. Is getting used to the central angle, how it relates to the arc and the arc measure, also how to label things. So any questions on the vocabulary before we go on to the examples?
How hard is it gonna get? Yeah, is it gonna get like a lot harder than this?
We're gonna learn this 12, 1, 2, and 3 are a lot of vocabulary about circles. So as long as you know your definitions, the math behind it shouldn't be too difficult.
Okay.
It's just a matter of it's kind of like when we were doing quadrilaterals, how it was more just if you know the right one and parallel lines, if you know the right angle pair, then the math wasn't really that hard. You just had to know the right pair. So it's a lot more like last semester where if you know your definitions, the math shouldn't be too difficult. All right, so in our first example, we're just naming arcs. So we're just practicing our labeling. So can anyone tell me 2 minor arcs that they see? Or even just 1 minor arc that you see? Reagan? Okay, so arc AB. That's this one here. Okay, Caitlin? B to D. Any others that you see? CA.
Can you go from A to C?
Yeah, so just like in lines, we're talking about the endpoint. So I could call that BA, DB, AC, and they're talking about the same arc. So switching the letters around isn't going to change it. They're the same thing. Okay, so there's actually at least one more in here. D to C. Okay, I only asked for 2, but I want to make sure you guys know that there's more than 2 answers in some of these. So just because you might see something different doesn't mean you're wrong. It just might be a different one.
Can there be A to B to D to C, like all 4 of them, or no?
Well, if we start at A and we go this way all the way to C, that's more than 180. That's more than a semicircle. So that's actually a major arc. And when we do major arcs, which is the next one, we only need 3 letters. So we can, so if we're talking about A, B, D, C, the key ones that we would need are A, pick B or D. You don't need both. Just pick one. A, B, and then ending at C. That's talking about the arc that starts here goes around and ends at C. So when you have a major arc, you might skip some points. You don't have to put every single point you pass in there. You just need at least one in the middle. See that right? Just write the equation in vertex. That's what you're converting to vertex one. Alright? Okay. So what's another major arc that you see? A, C, D?
Yes.
All right, A, C, D. There's probably more in there, but I'm just going to stop at 2.
I put BDA. That's a.
B, D, all the way around to A. That's a major arc for sure. Okay, what about 2 semicircles? Semicircles, we do the same as a major arc. We need to put a middle letter. B, D, C. And what's the other one?
AC.
So ABD isn't quite a semicircle. But we did BDC, BAC, the other half.
So a semicircle is like half of a circle.
It's half a circle. Okay, so some of the questions on your assignment, you're just going to be labeling. So finding in a picture and labeling. Okay. The rest of it, you're going to be doing stuff with actual measurements, like in these 2 examples. So when it comes to these 2 examples, what I would encourage you to do is start by labeling everything you know, because then it makes going through the ABCD really fast. So when I look at this picture, I have a central angle of 32. So what does that mean about this arc? It's 32 degrees. It's the same. If I know this arc is 58, what do I know about this angle? It's 58. Okay, I actually know a little bit more. I can figure out what AB is or BA is. Anyone know how? It's a semicircle. So CA is a diameter, so 180 minus 32. This is 148. So this inside angle is also 148. And then what about the other side, AD? Okay, that's one way to do it. Add up the 3 you know and subtract from 360. Or if you recognize that you have another semicircle, 180 minus 58 will give you 122. So you'll have 122. So this is where I was meaning you're going to use these 360s and 180s a lot depending on whether you have a semicircle or a full circle. So now let's go to the questions. What's BC? What's ABC? 180. So A through B ending at C. What about BD? 90, because we'll just add up these 2 together. And what's AB? 148. So by taking just a minute to fill in what you know on your circles, it'll help you go through those questions to the right real fast because you'll already have it all labeled.
So that's the only thing on homework?
Let's get through the second one. Okay, so again on this one, I'm going to try to fill in everything I know. So can someone tell me something that we know?
Or all of them on a set?
Okay, which interior angle do we know? Okay, so DOC we know is 73. Which other one do we know? AOD, what's that one? Can we figure out this one here?
Yeah.
How? add the three together and subtract from 360. So when you add 107, 70, and 73, that'll give us 180 plus 80 is 260. So what's 360 minus 260? 100. So that also means that AB is 100, or arc AB is 100, and arc CB is 80. So let's see if that helps us get through all of our questions. So what is the measure of AB? 100. What's the measure of arc ABD? AB all the way around to D. 253. How'd you get 253? Okay, so you can add up the three arcs. So 100 plus 80 plus 73. Did anyone do it a different way? You could also do just 360 minus 107, the one arc that you're not using. That would be another way you can go about it. Okay, what about arc DCB? 153. How'd you get 153? Just added them together. Okay, now what about this last one? The measure of angle ACB. Okay, what's different here? Are we talking about an arc? No, we're talking about an angle. So which angle are we talking about? We're talking about angle ACB. So we're talking about this one right here. Is that a central angle? No, so we can't say that it's 100. Okay? Huh? It's not 180.
Wait, don't triangles add up to 180 though?
Triangles add up to 180, so... Huh?
50, right?
How'd you get 50?
Because, so you subtract 80 from 180, and then you divide that by 2.
Now, why did you divide by 2?
Because we're missing 2 angles. And those are, I forgot, isosceles.
Okay, we have an isosceles triangle here. So we are going to have isosceles triangles come back at us. But because in a circle, all the radii are exactly the same, that whenever this happens, we know we have isosceles. Meaning these two angles on the bottom have to be the same. So we can do what we did with isosceles, 180 minus the vertex angle divided by 2 to get each one is 50 degrees. So you'll also have some on your homework that switch it to an angle instead of an arc. So make sure you guys are looking at the symbols so that you get the differences. Krista?
How did you know to put like a little arc thing or that central angle thing on there?
This one?
Yeah, those two things. How did you know to put that?
These two here?
Yeah.
Because it was asking me about those angles, so I wanted to make sure I was looking at an angle, not an arc.
And then you subtracted by 180 because it's half of it.
So I looked at, if it helps you, you can draw this triangle separately, where we have an isosceles triangle with the vertex angle of 80, and we're looking for the two base angles.
Oh yeah. Okay, that makes sense.
So if it helps to remove it, then you can sketch a little drawing to the side and do it that way.